continuous deployment of your application. So before we go to the main topic, we're going to say a few words about ourselves.
So I'm Cora Iberkleid. I'm a senior platform architect at Pivotal. I've been there 3.5 years. I work a lot with Pivotal Cloud Foundry, of course, and cloud native architecture, and generally helping enterprises modernize their development practices.
My name is Marcin Grzejszczak. It's impossible to pronounce my last name, so if you want to find my Twitter handle, just go to my blog, toomuchcoding.com. And I work in the Spring Cloud team. I'm leading those 3 projects, Spring Cloud Sleuth, Contract, and Pipelines. And we're going to be talking about pipelines today. So whenever you go to a conference and you hear about a new fantastic tool or a fantastic approach, you shouldn't be going back home and just using it, because it's I think called conference-driven development. So you should ask yourself a question, what problem does it really solve? Because if you don't have a problem, maybe you shouldn't be using it. So the problem that we're trying to solve is the necessity to create a deployment pipeline from scratch for each new project. Who of you had to, at least once in your developer's lifetime, create a deployment pipeline? That's pretty much expected. So everyone. So what is Spring Cloud Pipelines? So it's an opinionated template of a deployment pipeline. It's a GitHub project. And it's based on good practices from different projects. It's not like somebody woke up in the morning and said, had a vision that this is the way you should be doing deployment pipelines. It's much more complex than that. And we believe in the infrastructure as code approach. So what does it really mean? It means that, for example, you have an automation server and it goes down. We don't believe in the case that you have this server that you cherish and you click around and it's been there for ages. Because if there's fire in your company and this server goes down, you'll cry because you love the server and it's dead. So no, that's not the way to go. We prefer to have things coded. So if something goes wrong, you can recreate it, regenerate it from code. So automation server setup should be automated too, right? So you shouldn't be clicking all those checkboxes in Jenkins, for example. It should be, let's say, it should come from your code. You can even write tests for your pipeline. So if your pipeline is code, you can write tests for your code because, of course, everybody who's here is even starting from tests, right? You never do skip tests or to do, I will write tests afterwards, right? So you don't do it. I respect this. So we support following automation servers out of the box. Concourse. Who knows Concourse or uses Concourse? Great, quite a few people. Jenkins using Jenkins job DSL. Who knows Jenkins job DSL? That's really nice. And who uses Jenkinsfile? So the pipeline plugin. Okay. And who doesn't care? Okay, quite a few people. Good. So logic of all steps in Spring Cloud Pipelines is done via bash scripts, right? Which means that you can convert the internals to suit your needs. So if you don't like the way we've done this, in this opinionated way, you can easily change it. And actually, you can use whatever automation server you want. Because these are bash scripts. It's enough to execute them and set some environment variables. We support Maven and Gradle out of the box. If you use Maven wrapper or Gradle wrapper, we see it, and we're going to call proper tasks. And since, as you are, we're also automation freaks and test freaks, we have written over 150 BATS tests. So if you right now want to just go because the topic is not interesting for you, just take it with you. There is a framework called BATS, which is an awesome framework to write tests for Bash. So if you want to know more about this, we can talk after the talk. So this is Spring Cloud Pipelines. It's a GitHub project. It has various folders. Oh, you can see what I'm showing. So I'm going to just describe it, or actually I have a big arrow. So there is a common folder. So let's go to this common folder in which we have a lot of bash scripts. So each of those bash scripts, or most of them, represent a single step inside the deployment pipeline. So let's check out build and upload sh. So if we go here, we will see that there's not much really there, right? So what we have there is essentially executing a function called build and sourcing a file called pipeline.sh. So what is it? If we go to pipeline.sh, we will see, I don't know if we're the first in the world, but most likely not, but we have invented, if we are the first, interfaces in Bash. So we have a function that just echoes and exits 1, right? So it doesn't really work. So it's up to you to override this function with some logic, right? So this is an interface in Bash. And there is a pipeline-maven.sh, so there's a lot of like analyzing your code. So we say, oh, you're using Maven. So there's a file pipeline Maven in which we define what build is, right? So that's the idea of like certain conventions inside the code. Now, we have different platform as a service types. So we have pipeline-cf and pipeline-kate. So we support Cloud Foundry and Kubernetes. Let's check out part of pipeline CF. So over here you can see an example of let's say one of the last steps, complete switch over, which essentially, let's say, deletes the old app and stops the old app and if it's present, etc. So for Cloud Foundry, you have a specific script for case you have another one. If you had yet another platform as a service type, you would just add a new function, a new script that follows this convention. So it's all convention-based. So this is how the deployment pipeline looks like, right? I'm pretty sure that you can't read it, but don't worry, we're going to zoom in a second. So Concourse, for those who don't know Concourse, each of those boxes is a job that has a couple of steps in it, a couple of tasks. So this is how you configure it. It's part of the Concourse pipeline. So here we have a job which is called build and upload. It has a set of inputs. So those, oh, you can't see it still. It like has inputs with those get keywords like tools, repo, keyval, whatever it is. Then you have a task which processes the inputs, and then you have the outputs, right? So this is the idea of Concourse. You have something coming in, something processing it, something coming out. Jenkins job DSL. So this is the code written with Jenkins job DSL and delivery pipeline view. So we go from left to right via stages. So we have 4 stages, build, test, stage, and prod. And in each stage, we go from top to bottom, right? So from build and upload to API compatibility check. And you can press the arrows to restart the job. How do you define it? Using a Groovy DSL, which is typed. So you can add to your project the Jenkins job DSL dependency and write code, which you can also test. Your IDE will help you. Jenkinsfile with Blue Ocean. So if you have never seen this UI, this is called Blue Ocean. So you have a Jenkins, you can install a plugin called Blue Ocean, and now it's less hideous than ever before. So here you start from left to right. The funny thing is, I don't know if they fixed this bug, but if you're, for example, for some reason, I don't know, you lost internet, your end-to-end tests have failed. In order to restart the job, you have to restart the whole pipeline. So yeah, it takes some time. This is how you define it. It looks kind of groovy, but it's groovish because you cannot write just in groovy. It has certain syntax. I never remember the syntax. You can install a GDSL file only for IntelliJ, so it doesn't work for any other IDEs that will help you with the syntax, but it's not coming from like a library from compiled classes, so you don't have a lot of help. So what are we going to work with? In my section, we're going to have such a flow. We have let's say, GitHub that is emitting hooks like HTTP calls to an app called GitHub Webhook, which is converting the stuff to some objects and sending via AMQP to GitHub Analytics. And we're going to be focusing on that project more in my part of the presentation. So before we go there, we should ask ourselves a question, like philosophical question. Why do we deploy software? Believe it or not, we're paid for delivering business value, not to play around with cool technologies, or unless you're in Spring Cloud team. But other than that, like this is my business value. So we're paying for delivering business value. If you go to production with your code, you're starting to deliver business value. The test environment doesn't really matter. Features are only done when they are deployed to production. Let's never, ever forget about this. And it's better to deploy frequently for faster feedback, right? I mean, I know that none of you here is deploying software like every 6 months. You're doing it daily, a couple of times per day, right? But there are some companies out there that deploy every 6 months, every year. So it's not what we want. We like to deploy like more frequently because from the technical perspective, we prefer to deliver small chunks of code because it's easier to comprehend what has changed. And from the business perspective, the business can see whether their ideas make sense or not much sooner. So what I wanted to show you that unit test passed, but integration test failed. So we don't want it to happen anymore. Yeah, so yes, we're here, faster feedback. So what we want to achieve is actually to fail the deployment pipeline as fast as possible, right? We don't want to wait until the end of end-to-end test to finish to see that something is not wrong. For example, integration with your HDMI, right? So we want to introduce standardization. So we want to deploy stuff in the same way in an automated fashion. Why? Because if you do stuff in the same way, it lowers your support costs, right? Because you can rotate people much easier. Everybody's doing stuff in the same way. If in automated fashion, who has heard about GitLab.com problems? Yeah, like 300 gigs of data lost because somebody went manually to the server and clicked something on the master node instead of secondary. I mean, it happens, right? And your deployment pipeline should test rollback. Because if they do, we can do A/B or zero downtime deployment. So how does Spring Cloud Pipelines help us with this section? So deploying frequently and failing as fast as possible. So these are the two steps of the pipeline: build and upload, and build API compatibility check. So the problem we have is slow feedback, right? We don't want to wait until the end of end-to-end test steps to see if something goes wrong. We want to fail during build time. On our laptops would be the best. If integration is faulty or if our API is backward incompatible. We don't want to wait until the end-to-end tests got executed. So you're going to see quite a few Captain Obvious solutions. So if the problem is that you're not failing fast, start failing fast. So how can you do it? With unit and integration tests, nothing special, right? But you can use contract tests. For example, Spring Cloud Contract for HTTP and messaging. So tomorrow I have a talk with Adip Saikali about Spring Cloud Contract for an hour. Today I'm going to show you that in a minute. So if you're lost, you're invited to come tomorrow. So what happens is the producer defines a contract. A contract is an agreement between the consumer of the API and the producer of the API on how the communication should look like, right? It's not a schema, it's a scenario. And now from the contract, tests are generated to see if the producer is not lying, right? Because if you provide in the contract a statement that, hey, I have an endpoint foo, if you shoot a request there, then life's going to be better, and you don't have this endpoint, then we have a problem. So we want to generate the test to see if you're not lying. And then we generate also a stub, right? So consumers can reuse the stubs without running the producer. That's the idea, right? Because we don't want to always run the whole, application of other dependencies like other applications, right? So we want to fail at build time if integration fails. So we want to fail fast. All stubs are sent to, some storage like Nexus or Artifactory, so they can be reused. So now time for the demo. You're going to see some code on the slides, so for sure it's going to compile. Here's an example of a contract for messaging. So we have some description. We have a label, issue created v2. Let's remember that name, issue created v2. And we say that, with messaging, something triggers a message, right? It's not like with HTTP that you send a request and you get the response. Something has to trigger the message. So in our case, some method called createIssueV2 will trigger a message, and the output message will be sent to a destination called messages, and there's going to be some body there. The body will contain username and repository fields, right? So that's the contract. From this, tests are generated. So we said that if the method createIssueV2 is executed, a message will be sent. So the test checks if there is a message sent to a destination messages, and whether the response contains in the body username and repository fields, right? Because if you provide this in the contract, we need to check it. So the consumer creates a POJO saying, okay, username repository, that's what you said in the contract, so I trust you. And now we write a test. So this is an integration test, should store a new issue, in which we say, okay, initially we had no stored issues. So if we trigger the message using the label, issue created v2, if we do this, then we should have one stored message, right? Makes sense. 0, a message arrives, we store the message, so we should have one. And we're using a part of Spring Cloud Contract, I don't know if you can see that. Oh, you'll see. Auto-configure Stubrunner. So a Stubrunner, believe it or not, is running stubs. So it downloads the stubs of the other application, starts it in memory. If you're using HTTP, it starts a fake HTTP server called wiremock. If you're using messaging, you can, using the label, trigger the fake message from it. So the test passes, life is great. And now, let's say that the producer was unfortunately drinking at work, and he has made a backwards incompatible change. He changed the name, let's say the fields in the body, from username and repository to user and repo, for some reason that we don't understand. It's a breaking change, right? So this villain has uploaded the stubs somewhere to some artifactory or wherever, and suddenly the consumer is broken. Why is it so? That's because this test is downloading the latest stubs. So if the producer has broken the compatibility, uploaded the stubs, then we in the consumer tests download these stubs. And by the way, you can see that I caught the screenshot when the test is running because there's suspense here, right? The tests are running, we don't know if it's going to pass. And actually, it's not going to pass because we want to inject the, when we deserialize, we need the repository and username fields, but they're no longer there because the producer has changed in a breaking fashion the fields. Who understood anything of what I just said? Okay, quite a few people, good. So that kind of makes sense. So let's say that we wouldn't want to break the consumers. We would like to, if we were doing a breaking change, we would like to fail on the producer side, right? So how can we do it? Let's say that we have v1 of our application that has an HTTP endpoint called delete. With the method delete called issues, right? If you send a delete HTTP request to add issues, then something will happen. So we define a contract that exactly does this check, and that auto-generated tests get executed for this contract. So a contract saying delete issues. If you send such a request, the response will be 200. A generated test on the producer side saying, given I send the delete to issues, respond with 200, right? And we went through the deployment pipeline, right? Everything is awesome. So now, again, for some reason, I decide to delete this endpoint because I think it's a good idea, right? So I remove the endpoint, and I remove the contracts. So no longer the generated tests are there, right? If you don't trust me, I created a patch that I put on the slide showing you I deleted the endpoint and I deleted the contracts, right? And I went through the deployment pipeline. Great. So now what we want to check in terms of the API is whether my application in version v2 is compatible with the contracts from version v1, which is on production. Meaning, is my application's API currently compatible with the API of the application on production? So what will happen from the contracts of v1, tests will be generated and executed. The test will be executed against v2 of the code. And now, animation is going to fail. And for a reason over here, because the current implementation v2 does not support old contracts v1, right? Because this test will be generated, and remember, there is the patch, right? Removed endpoint. So a request will be sent to the endpoint that doesn't exist, and in the deployment pipeline, you will see expected to 100, but have 404. So that was fast. And you can run those things from your laptop. So imagine how much money you can save on failing on all those typos, integration things on your laptop instead of running those 5-hour end-to-end tests, and to see at the very end of those tests, all the 10,000 tests have passed and one failed due to typo. Been there, done that. It's terrible. Okay, standardization, automation, and rolling back. So we go further down the pipeline. Test deploy, test smoke, test rollback deploy, test rollback smoke. If we standardize, we lower the support costs, and we can rotate people more easily. Everybody's doing stuff in the same way. So if you're using a platform and certain tooling, you can standardize the way you deploy, monitor your software, or do some sort of upgrades. So if you use a PaaS, you can, the first two things can be standardized, so deployment and monitoring. So Spring Cloud Pipelines supports Cloud Foundry or Kubernetes as implementations. You can use PCF Dev or Minikube. We work with that. So why could you use a PaaS? Why does it make sense? That's because you abstract the way you govern the infrastructure, so it doesn't matter if you run your PaaS on Amazon, Google, Azure, or your laptop. You do stuff in the same or similar way. Now, if you're doing database migration, so about the tooling, if you're doing a database migration, you can do it via tools like Flyway or Liquibase. So these are tools that allow you to start versioning your schema and the schema changes. So let's focus on those two steps, test deploy, test smoke. So when we do test deploy, what happens is we deploy the application to some test environment. So in Cloud Foundry, that would be a test space. And the database schema gets updated upon application startup, right? Application starts, database gets updated. And then we run a handful of smoke tests to see if crucial parts of the applications are working fine. Why do I say handful? Because I worked with some QAs that wrote end-to-end tests and UI tests for every single feature. So there was a feature that gave us $1 per year. So they had to write an UI test for this that costs $100. So after 100 years, you'll pay it off. Makes no sense, right? So it's better to test only the crucial bits. So if your app has 10 features, 2 of them are crucial, test these 2 things only because you have already tested the rest in unit and integration tests during the build. We want to test if the app is properly packaged. That's another thing. And now, this is interesting because we will deploy our application, we will use a real database, but we will not call real applications. We'll have everything, all the applications around us will be stubbed. And we can use the Stubrunner application that actually can also be run as a standalone process and deployed to Cloud Foundry. And you can tell Stubrunner that, hey, please download those 4 stubs and run them on some fixed or random ports. Problem, rolling back the database. Who here in their deployment pipeline is checking if the application can be rolled back? 1, 2. Okay, that's more than expected. So deployment pipelines should test whether you can roll back the app, right? And rolling back the database is extremely difficult, right? Other companies, like I said, are doing deployments every 6 months, so they have really big problems, because they have a lot of changes. So most likely somebody deleted a column, right? So how will you roll it back? So let's see those 2 steps. Test rollback deploy, test rollback smoke. Captain Obvious solution. If the database rollback is problematic, don't do it. As simple as that. So what can you do? Let's try to do only backward compatible changes of the database. Or you can read my blog post at Spring.io to the bottom. You can't see it, but type in 0 downtime deployment with a database, and you will see how to perform a backward incompatible change in a backward compatible way. That's possible. 4 deployments or 5, and you're done. And if you know that you have to do it, you will think twice before doing a breaking change. You can roll back the app itself, not the database, just the jar, which means that the application and database have to be compatible. Why? Because we want to achieve a goal where we have the new version of the database and 2 versions of the app running, the old and the new. Right? This is our goal. A demo. So we have, let's say, GitHub Analytics in version v1 with code in which we have, like in Hibernate or whatever else, we are going to store information in a column called repository, right? In the database, we have in the schema, we say there's a column repository. We've gone to production. We have created the flyway script. So we say that create table issue, and there is issues, and there is a username and repository columns there. We go through the whole pipeline. We've gone to production. So this is our schema, repository, username, right? Now, again, somebody had a great idea and renamed the column from repository to repo. Why not? It's shorter, right? So in the code, we have repo, and in the database, we have repo. So he has created, or she has created, a script called v2 breaking changes, just a hint. And we alter table issues and change repository to repo. So what happens is we have a column called repo, right? So what can we do now? Let's see if the jar from production can actually work with our new version of the database, right? v2. Animation, disaster, and let's see why. So we go through these steps. Test deploy. We upgrade the schema to v2. So new application works fine. The jar in v2 works fine against the database in v2, right? Now, this is red for a reason, because here we deploy v1 and connect it to this v2, right? And here we execute the smoke tests of v1. But the old application v1 can't work with the new database because it tries to inject data to a column called repository that doesn't exist in the database. So if you check out the logs of the app, you'll see unknown column repository because it's not there, because somebody has rename the column. So that was test, now stage. So until now, we saved a lot of money because we executed very fast tests, either on your laptops or on Cloud Foundry in a space that is, let's say, isolated only for your application, surrounded by stubs. It's extremely fast. And we have tested that we can, have 2 apps running at the same time. So time for controversy, because I have a problem with end-to-end tests. Even though in Spring Cloud, I think I wrote plenty of end-to-end tests. So that's really bad. But I don't like them. End-to-end tests are slow and brittle. And QA departments love end-to-end tests and write them for every feature. Now, setting up the end-to-end test environment. I love these discussions. Will you have one environment shared between all applications? If that's the case, if end-to-end tests take an hour to run, you have 50 services. You have to wait 49 hours for your turn, right? And then you have a typo in the API, and you have to run again after waiting 49 hours, right? So one environment per application. Fair enough. Who's going to pay for that? Okay, we're happy. Surrounding apps should be deployed in production versions or development versions or both. Because if both, then you have to wait 96 hours for your turn because everybody's going to run the test twice, right? First for the production versions, once for the development versions. Another problem, who has a separate team that has to do data obfuscation to put the data into this test or QA environment? Anybody? Okay, one person, quite a few people, expected. So for security reasons, for the rest of people who don't have these problems, there are companies where you cannot just take production data and put them into a stage environment. You have to either generate it, which sometimes it's impossible because you have some, let's say, business logic, or you have to create a new project whose only, let's say, responsibility is to obfuscate the data. I've been in this project. I think I wanted to quit immediately. It's not the best project ever. So if end-to-end tests are problematic, maybe don't do them, right? Because regardless of the time you spend on QAs, UATs, and stuff like that, you can still have bugs in production, right? Because the only place that tests your production is production. So assuming that you have a long discussion with the business, and you say, if we don't want to do end-to-end tests, we have to embrace failure because most likely sometimes things will not work. Do we accept it? Let's calculate if we can accept this risk, if it makes sense, right? Because if it doesn't, of course, you should be doing end-to-end tests. If you introduce monitoring of your business key performance indicators, so metrics for your, let's say, business-related features. So in our case of this demo, if we are storing issues and we have a lot of traffic, I can create, for example, a KPI or a metric that if I go below 10 issues per second, then my system is in terrible shape. So I should be notified on PagerDuty or Slack that something is extremely wrong. I should know this immediately, especially after deploying, right? So if I deploy a new version without doing end-to-end tests, I need to see if things are working fine. We have those alerting. We know that we can roll back on production because we went through the pipeline. You could theoretically stop doing any end-to-end tests. There are, let's say, very interesting articles out there. You can read about them. But anyways, we have it because it's controversial. So both of these steps pretty much will be manual because most likely you need to wait for your turn and you have to do some manual work to purge stale data, set up some applications, etc., etc. Okay, time for production. So production, deploy, complete, and rollback. What are the problems with deploying to production? Who loves deploying to production at night? Nobody. Okay, that's expected. So I was doing deployments at night, and it never worked. It did work, but only until the first shift arrived, because it turned out that my clicking around wasn't enough, and I didn't click somewhere that something didn't work. So eventually, in one of the previous jobs of mine, what we did is we started to deploy exactly when everybody was at work. That's because we immediately knew that something was working fine or not, and when the developers know that they can seriously break stuff because we deploy it at 9 a.m., then they think twice before they merge their stuff or they write tests. We would like to treat a production deployment like any other deployment. We could even forget that we're doing deployments, right? After merging to master, it goes to production. And we would like to do A/B testing and zero downtime deployment to be less scared of those things, right? And if something goes wrong, we would like to go to the pipeline, click stop, like rollback, and know that we have the previous version, and we know that it works, right? So the solution is to use a pass and Spring Cloud pipelines. We have our monitoring of KPIs, so we know immediately that something goes wrong. We have the alerts. We know that we can easily roll back, so we can click a button and just roll back. And it's the platform that can take care of zero downtime deployment. And how does it look? We're going to see that in a second. So if we do prod deploy, we deploy the pipeline version of the application to the, like next to the current production one. So you have something running on production. If you have gone through the deployment pipeline, you deploy your version next to the one that we have currently working on production. Once it's happened, we tag the repo with prod/version number. We need this tag for API compatibility tests and for the database rollback tests, right? We need to know what is the most recent version that has gone to production. And now prod complete, when you click it, you stop the old instance and leave only the new one. If we click rollback, we delete the new instance because you said, hey, this is seriously bad. Let's revert this. So we delete the new instance, remove the tag, and we leave only the old instance running. So we're going to see a fantastic demo. This is the whole demo of how to do zero downtime deployment on Cloud Foundry. So if you can see anything, we have two applications, GitHub Analytics and GitHub Analytics Venerable. I'm Polish, I didn't know even what venerable means, but yeah, I took it from a plugin, so. Anyways, this is the old instance. So assuming that you had only GitHub Analytics on production, when you deploy the new version, GitHub Analytics gets renamed to GitHub Analytics Venerable. So this is the old instance. This is the new instance. And what's crucial, both are registered under the same route. So it's Cloud Foundry that routes the traffic. So you have two instances running at the same time, and Cloud Foundry takes care of, let's say, routing the traffic. You have zero downtime deployment. OK, so that was the introduction to the whole like Spring Cloud Pipelines project, how it works, what are the different stages of it. And hopefully in this version of the presentation, we have your slides.
Yeah. Oh.
Do we? Oh, this means loading.
Yeah.
Oh, we do. That's a surprise.
Great.
So now off to Cora that will explain how you can migrate your current application to work with Spring Cloud Pipelines. There you go.
Thank you. This one, right?
It should work.
OK. Great. So the next question is, you have some apps. How do you make your apps run through the pipeline? So I'm going to tell you an application refactoring for Spring Cloud Pipeline story in 3 acts. So first, the premise of the story. I'm going to learn Polish doing this.
This means loading.
So if you take one thing away from this presentation, it's Polish for loading. So the main characters of our story are Simon, and then we have Greeting UI and Fortune Service, who are from the Spring Boot family. And we have Fortune Service's very good friend, Fortune Database, who is from the MySQL family. We have a supporting cast of characters. We have the Spring Cloud Services triplets with their pet rabbit. Sorry,
Yeah.
It's going to be a slow story.
Maybe we'll switch to yours again.
Yeah?
Can you do it? I guess they'll have to, like do something with edit the video anyways, right? So
That's a lot
like
of
if you feel
editing.
more comfortable, we can switch.
Yeah, maybe.
Any questions so far?
Sorry.
No questions? Like everything? Do you like the pipeline? Yeah, there was a question here.
How do you pronounce loading in Polski?
So loading in Polish is wczytuję. Wczytuję. Yeah, that was a good question. Any more questions? Like,
OK, I'm going to switch back.
yeah, the question?
You showed a pipeline in, I think it's Concourse.
Yes.
They run in Jenkins.
So you were sleeping, I guess, at the beginning, but it's not a problem. It's not a problem. So
No mercy.
I get it. I get it. Yeah, I'm also tired. So we support Concourse, Jenkins with Jenkins Job DSL, and Jenkins using Jenkinsfile, so this pipeline plugin. But since everything is using Bash, you can run it with anything. Actually, you could even run it manually if you provide all the environment variables, which is kind of stupid, but you could do it. Any more questions for now? Yeah, go ahead.
So like you're saying maybe like skipping unit testing. So like what's your view on like acceptance testing or behavior-driven development, which kind of you to do
Oh, I love acceptance test-driven development. So you can do it in isolation for a single app, and then, for example, we'll introduce some tests on production, but you have to understand the cost of it, right? Absolutely, right? So if you calculate it, it makes sense, because at the end of the day, all your decisions have to make, they say, financial sense. I was in one company where a developer said, I need Mongo, I need it right now. I just need it, it's essential. And I asked why? Because I need to store JSONs, right? So it turns out that Postgres can do it too, and we have it. So you have to, calculate if it makes sense. If it makes sense to do zero downtime deployment without end-to-end tests and just go to production, sure.
Okay, so back to the story. So our story takes place across the land of Pivotal Cloud Foundry and Concourse and the neighboring lands of Artifactory, Bintray, or Nexus, and GitHub. So we begin our story with Simon, who's a very friendly guy. Simon's walking down the street and sees Greeting, decides to call out, hey, Greeting. Greeting's also very friendly and likes to interface directly with people usually, but doesn't really know what to say. So Greeting really wants to reach out to his brother Fortune to figure out how to respond to Simon. Looks around, Fortune's not there. But luckily, the Spring Cloud Services triplets are around. One of them is Eureka. Eureka always seems to know where everybody is. So Greeting can ask Eureka, where is Fortune? And Eureka says, right there. So now Greeting can ask Fortune, hey, how can I respond to Simon's request? Fortune says, don't worry, I got your back. I've got this really good friend Fortune database full of things to say. Fortune database says, of course, just tell him to tell Greeting this, or tell him to tell Simon this. Fortune passes the message on to Greeting, and Greeting can tell Simon, do what works. Simon's really happy with that. He thinks that's really great advice, so he wants to know who said it. So Greeting tries to ask Fortune, but they're not equipped to handle that kind of question. And even if they were, Fortune doesn't know if database has that information, how to ask database for that information. They don't know how to handle this conversation at all. So they start trying to cobble it together, but really it's a very messy road, a lot of injuries on the way. Simon's getting a little bit impatient. It's not that hard a question. At some point, Greeting can't even talk to Fortune anymore, starts using its Hystrix fallback responses, and the whole village is aware because the Hystrix dashboard in the Spring Cloud Services triplets is announcing that information to the world. Simon just wants to know, and it feels like the whole world is falling apart. Simon knows a little bit about development, so he really just wants us to pipeline all the things so that this problem can be solved. So that brings us to the first act of our story, which is the beginning of refactoring Greeting and Fortune in order to avoid this kind of situation. So one thing that you can take away from this structure of Act 1, Act 2, Act 3 of the stories is that this is an approach that you can take in refactoring your application, sort of set this up in stages, in milestones of refactoring. So stage 1, Act 1, is the scaffold. The objective of this stage is to automate the deployment of Greeting and Fortune applications, right? Just make the pipelines run green. In doing that, we're also going to establish the Cloud Foundry spaces that are in accordance with the recommendations from Spring Cloud Pipeline. Marcin already showed you that 4 stages: build, test, stage, and prod. Build happens on Concourse, so really we're talking about a test space, a stage space, and a prod space. Our approach is to make minimum changes to our applications. We really want to not make any code changes at this point, just scaffolding, then create a pipeline for each of our 2 applications, create the spaces, and run the pipelines. Greeting and Fortune, just a little background on them. They're Spring Boot applications. The source code is on GitHub. They're built with Maven. They don't have any tests in them because despite what Marcin thinks, not all of us write tests. And altogether, they use 5 services. They each use the 3 Spring Cloud services for the cloud config. We also use a Rabbit MQ, and Fortune Service uses MySQL database. All of these can be provisioned on Cloud Foundry, but the pipelines would also work with services that are outside of Cloud Foundry. So the first thing you need to do is add a couple of branches to your applications. The version branch is required by the pipeline. It will use it to upload the version of the pipeline every time you run it from the beginning. The generate version job, which is the first job in the pipeline, uses this branch. A recommendation is to create a second branch so that you can make all of these refactoring changes that we're about to go through. The pipelines require Maven or Gradle wrappers. If you don't have the actual wrappers, you can build the applications on your local laptop, but Spring Cloud Pipelines won't be able to do it, so you need to add the wrappers. The pipelines also need to be able to access, locate and access your Artifactory repository, whether that's Nexus or Artifactory or bin tray. So we need to provide that information. You can provide it locally on your machine as well, but you really need to put it in the POM file. And then you have to push those changes. Those changes have to live on your source code repository with your project. Then there's pipeline configuration. There's certain configuration that you're not going to push onto your application because it's credentials and things like that. This is just information the pipeline needs when you do your fly set pipeline command. So it's your Git information, your Git private key, your email, your name, and it's the Maven repo information. You also have to tell it where the source code repository for the actual Spring Cloud Pipelines code is. So what Marcin was showing earlier. And if you were to do this right after walking out of this room, you would want to use the CF branch. If you give us a little bit more time, as soon as M8 is released, you can use that one, which should work out of the box for deployments for Cloud Foundry. If you've done all of that, you can actually get through all the build jobs. So all of the activity that happens on the Concourse workers will work at this point. So you're building jobs automatically. You are also having the pipeline automatically upload those jars to your artifact repository, and you're tagging your Git repository with dev in the version. So you've already accomplished quite a bit. The API compatibility job won't do anything until Act 3 because that's for based on contracts. And all of this, as I said, is taking place on the Concourse worker. So in order to get to the next stage, which is on deploying onto Cloud Foundry, we of course have to add Cloud Foundry related information. So your application is going to need a manifest. If you, for some reason, have no manifest in your code repository, you need to add it now. You're going to need a second manifest. So this second manifest is specific to Spring Cloud Pipelines because in the application manifest for Cloud Foundry, you have a list of services, which is just a list of logical names, right? Fortune database, config server, but that's not enough for the pipelines to know what kind of CF create service command or CF cups command to generate from that. So we provide a second manifest that has all of that information. Here, these two examples use a type of broker, so that will translate directly to CF create service. Cups is supported, and the pipelines can also deploy an application and expose it as a service with type app. So you push those changes up as well. We're showing here also the test section. So these are the services that will be created in the test environment. This is required. And optionally, you can add a stage section if you want the services in the stage environment to be dynamically provisioned as well. So the pipeline configuration. So the next thing is that we have to give our credentials to Cloud Foundry to the pipeline. So first, we give it a paths type in the same credential files where we had put the Git credentials and the Maven credentials. Now we have to tell the pipeline this is Cloud Foundry as opposed to K8s. We're telling it also where to find that Spring Cloud Pipelines manifest file that we just created with a list of services and how to create them. And it gives us the opportunity to give a hostname UUID, which is really useful for deployment targets like PDubs, where you might be competing for hostnames. So you can put a UUID, and that'll generate a unique bit to your hostnames. You add the target and login information for each of your environments, so they can be 3 different foundations, they can be 3 different orgs, or 3 different users, or all the same, it doesn't matter. And the test space prefix, the stage name and the prod space name that you provide are used as is, because those are assumed to be shared with other applications. The test space, as Marcin also said, is to be isolated just for your application. So Spring Cloud Pipelines will take it as a prefix, and it will automatically append the application name to the end of that test space. What it doesn't do is automatically create these spaces, because we're not assuming that the users that you've provided actually have org manager rights, right? They might only have rights over the space, and the space would already have to be created. So you do have to manually go in there and create those 3 spaces. And remember that when you create the test space, to append the application name to it. And then you have to manually provision the services in production for sure, and optionally in stage. Once you've done that, you can run through all of the test jobs in the pipeline. So by the end of the prod deploy job, the Git repo will be tagged with a production version, and you have the prod rollback job there in case you need to trigger a rollback. So you're in pretty good shape. This is what it looks like when it's deployed on test. You can see that the application name has been appended to a prefix that we provided. And in prod, after the prod complete, we are in a state where only the new version is running, but we do have the option to roll back. So that's the end of the scaffold, right? So we've achieved this full automation of our pipeline. We can build, have the jars on Artifactory, tag the GitHub, et cetera, and we're following a certain convention in terms of our PCF spaces. So we can ask ourselves, is that enough? And the answer is no. Because it is easy being green if you're not doing any testing, right? We're not doing smoke tests, there's ETE tests, there's API compatibility testing. We're not doing any of it. So that gets us to Act 2, the test. In this act, we want to increase the effectiveness of the pipelines, increase our confidence in the pipelines, establish some sort of standardized approach across our development teams on organizing tests. We're going to use Maven profiles to control test executions. If you have existing tests, we're going to reorganize them to fit the structure that is suggested by Spring Cloud Pipelines, or add new tests if you need more test coverage. And we can also take advantage of this stage to actually enable the database back compatibility testing. So this is an example of one of the profiles that we have to add to each of our project's pom.xml files. So there's 4 profiles: the default, the API compatibility, smoke, and end-to-end. The one you don't add to your project is the API compatibility, because those tests will be generated automatically in stage 3. But for now, in the code, we match those profiles to a testing structure, right? So we have our E2E package, our smoke package, and then the other default tests. So we can start to, as I said, organize or add tests according to this structure. So for example, for Fortune, in our smoke tests, what's going to happen is the test is run from Concourse. It's going to call Fortune service and go to the database. So maybe the test we want to do is ensuring we have a successful response and that we're not getting the response that we hard-coded as the Hystrix response if the database is not there. So we're just ensuring that we're hitting the database. And Concourse is going to call Fortune service using this application URL that it will inject because it just deployed Fortune service. It has that URL. For an end-to-end test example, we might want Fortune service to actually have a call through greeting. In this case, because this is the test for Fortune service, Concourse doesn't actually have the greeting URL, but it can deduce it, assuming that the host name is the same, the structure is the same as the Fortune application, so it just does a quick replace. As you can see, it's circled in red. It replaces Fortune service with greeting UI, therefore being able to call greeting and making sure that none of the Hystrix responses are in the response. Similarly, for greeting, we're avoiding the circuit breaker fallback response in our smoke test, and the opposite in our greeting end-to-end. So more interestingly is the database rollback testing. So here we're going to use Flyway, this OSS database migration tool, to version our databases, create our schemas, and insert data. So previously, you might have been generating the schema through your JPA entities. So here we want to disable that. So you can see on the bottom right, we're saying JPA, DDL auto, none. And instead, we're going to explicitly provide the create table statement. We're going to put it in a directory that follows Flyway conventions and using a file naming that also follows Flyway conventions. So here we have v1 with a double underscore init.sql. So just by doing that, we have versioned our database, and we're allowing Flyway to generate the schema upon the application startup and keep track of the versions. For database population, we might have had some code inside the application, maybe using the command line runner. Instead of that, comment all that code out, delete it, and put your insert statements directly into the SQL file. So that when the application is started up, Flyway will populate the database, but it will only do it once per version. So you have that level of control that you didn't have before, because Flyway is keeping track of the database versions. And just like that, you're set up for database versioning and rollback testing. So not that hard. Which brings us to the end of Act 2. We've increased the effectiveness and the confidence in our pipelines, and we have a more standardized approach to testing across our teams. So we can ask ourselves, is that enough? We're in a great position. We have well-organized and robust testing. We're pretty confident in our pipelines. We can do safe rollbacks for database changes. But it would be better if we had a contract-driven approach We'll get more benefits out of it, partially for the pipelines, but also just general development practices and communication between teams. Our contract tests will catch API breaking changes much earlier. Normally, they would have been caught in end-to-end testing. Now we can catch them in build. Troubleshooting will be easier, and we'll get faster failure, faster feedback. So let's go on to Act 3, which is the contract. In the contract, we're increasing reliability. We're going to strive to maximize the benefits that we get out of the pipeline, and we're going to encourage contract-based programming across our development teams. We're going to do this by adding contracts, stubs, and a Stubrunner, and we'll enable API backwards compatibility testing. So we start with a contract. Greeting and Fortune have a pretty simple interaction between them. Greeting just calls the root of the URL, and Fortune responds with a Fortune, a string. So we put that in a syntax, groovy syntax, to really codify that contract that now both Greeting and Fortune can agree on in a much more structured way. That contract gets stored in the producer, in Fortune, under, again, following a convention, test resources, contracts, and then the name of the greeting application, and then the contract. The next thing we have to do is put the Spring Cloud Contract Maven plugin in the POM file of Fortune. So this gives us a little bit of automation magic based on that contract. This plugin is going to require a base class to help it build generate a context and to stub out the call to the database. So you can see here we built that context, and so this will generate a test that will comply with this, which is just to return foo Fortune. This is the auto-generated test. So we didn't even have to write this. This is auto-generated by the plugin. It'll generate the stubs, it'll generate the tests, and it'll put that all into a stub.jar. And now when that application is built, not only is your Fortune service jar file uploaded to Artifactory, but the stub jar file is also uploaded to Artifactory at the same time, even before you wrote any code. So now Greeting can start testing against our stub before Fortune has to do any work. So really a lot of benefit. For the back compatibility, however, we want to test against the we want to use the older contracts to test against the new code, right? Fortune can still use the current contracts to make sure that it's complying with the contract that we just agreed on. But what about the old tests? So in this case, for the API compatibility profile that we add to the POM file in the Fortune service, we want to enable it to go to Maven, look for the latest production jar file, the stub file, bring it down, and run those tests against the new code. So Spring Cloud Pipelines is going to inject the repository address and the latest production version into this to make that possible. So what does this look like? So from a greeting perspective, so everything we've talked about so far in Act 3 has been Fortune. So now we turn our attention to greeting. From a greeting point of view, previously, before Stubrunners, the app would have been built on Concourse, and any test would have expected the circuit breaker fallback response, or maybe you're configuring WireMock manually. Stubrunner will do that for you. So with Stubrunner, you don't have to rely on the Hystrix fallbacks. You can actually test against the contracts, and you don't have to do any of that manual WireMock configuration. So you can write these integration tests that are aligned with your stubs now. For the in-process scenario that we just saw on the screen, you want to set the client-side and the server-side ports for your calls. So that top configuration is basically saying, go get me this Fortune service jar file stub, get the latest version, and make the stub listen on port 9876 within the same process. And for the client call, we say, go to localhost 9876 to run that test. And that way we configure, that's the automatic WireMock configuration for the in-process tests. However, when we move to the test environment, now that we're deploying onto PCF, we run the Stubrunner as a separate application. So for Greeting UI, it's a much more real scenario. You might want to go back and review your smoke tests for Greeting, because now that you're hitting a stub, you're going to get a different response. So your tests are not necessarily built around the Greeting UI circuit breaker fallback response, but to something you'd expect out of the stub. So what does this mean? This means that we need a Stubrunner application, right? We haven't seen that yet. So don't worry, we have you covered. there is a Cloud Foundry Stubrunner boot application on GitHub under Spring Cloud Samples, Cloud Foundry Stubrunner boot. You can clone it if you want. You don't even need to. You can just, you don't need to fork it. You can just clone it, build it, and upload it to your Maven repo. Your Stubrunner app is going to need a manifest. All you really have to do is put the name of the app in there. That is going to correlate to the name of the app that you put in your pipeline descriptor file. So if you recall, we had created a second manifest for the pipelines to know how to create services. We're going to use that same manifest to have the pipelines deploy the Stubrunner application. So in this case, we're saying the name of our app is Stubrunner. The type is Stubrunner. So instead of broker or cups, this type is a special type called Stubrunner. Spring Cloud Pipelines is going to go to this location on the artifact repository and download that jar file, and it's going to deploy it, and it's going to use the manifest file that you created in the second bullet point, which really just has to have, as I said, the name of the app that matches the name of the app in this declaration. So far, so good?
Yes.
Okay. Oh, no, wait. Okay, that was good. Okay, so home stretch. That server-side, client-side port configuration that we did for the in process, we also have to do a server-side, client-side configuration for when it's out of process, at least for the moment. So for the server side, inside of the POM file, for Fortune, you say, I want you to put Fortune service listening on port 10,000. Spring Cloud Pipelines is going to put this information in the environment variables of the Stubrunner app, so the Stubrunner app can put the right stub on the right port. Client side, we can't go to Eureka to get, Greeting cannot go to Eureka to get the address for Fortune. It has to go now to Stubrunner on this other port. So we're going to add a non-load balanced template just for the smoke environment. And we're going to use an environment tagged application YAML file to provide the address to the Stubrunner. So we're forcing the client call to go to Stubrunner port 10,000. What is cool is that in the background, Spring Cloud Pipelines has actually started the Stubrunner listening with on multiple ports, which is not something that you normally do out of the box with Cloud Foundry. So what's missing here is just the integration, the final integration with Eureka, so that the address gets registered in Eureka in a way that makes sense to greeting. That's the only piece missing. So this is some extra configuration to do right now. So that's the end of Act 3. You've got your contracts. You've increased reliability. You can really maximize your benefits. You can start to use contract-based programming much more easily. So what have we achieved? We have full automation of our applications through our pipelines. We're automatically tagging GitHub repositories with versions and prods and taking away the prod tag if we have to do a rollback. We've increased test coverage. We've standardized the way we write tests across the enterprise. And now we're using contract-based programming. So finally, there's just one more thing. I'm just kidding. You're done. But really, you're just beginning. Because now you really can evolve your apps faster with hopefully better code, consistent testing practices. You can fail fast, get feedback fast, use contract-based API definitions, have rollback assurance for the APIs and database, and you have instant pipelines, right? Fly, set pipeline, and you're ready to go. So what about poor Simon? Simon still wants to know who said, do what works. But now that Greeting and Fortune are pipelined, Greeting and Fortune can agree on a contract for this new API. Fortune service can immediately publish a stub that both Greeting and Fortune can test against. Fortune and the database can agree on database versioning, which gives the database side autonomy to make changes as they wish. And Greeting and Fortune can instantly create pipelines to run through all these changes automatically and catch changes quickly. So now we can tell Simon that Pivotal says it all the time. To which Simon says, oh, right, I knew that. One last note. All of this stuff that I've showed you is actually available on GitHub, the Fortune Service app, the Greeting UI app, and there's 3 branches. There's 4 branches. The master branch has actually the original code before any of these changes, and then it's separated between phase 1, phase 2, and phase 3, so you can see the end state of each of these 3 acts. So that's the end of the story. Back to March.
Yeah, that's me. So this is the pipeline you could have seen in action. So how can you use it? So or how you can customize it. So if you want to start using it, you can either download it as a zip file, or you can fork it, whatever you want. But since we love automation, you're not going to click source, right? You can run this script to curl the latest version. There's also the Gradle W customize task that you can run that will remove some things for you. But if you're doing some further customizations, please let us know. There's an issue 55, very important issue in Spring Cloud Pipelines, where you can say what customizations you've done, because if multiple people do the same customizations, we can put them in the automation process, right? So you just do Gradle W customize, and you'll be able to provide like some other customizations. So summary. So with continuous deployment, we have managed to continuously deliver business value. Business value equals our wages. Remember about this. Spring Cloud Pipelines gives you out-of-the-box tooling to test your software via different testing strategies, like union integration, contract, rollback. And you can gradually migrate your application to start using Spring Cloud Pipelines. Like, it wasn't a lot of work, right? So it's feasible. And since everything is using Bash, it's easy to adjust it to suit your company's needs. And thanks to the platform, you can do A/B and zero downtime deployment without any issues. So I guess some questions will be right now. And we're going to leave those links, I guess. So here you can see the links to GitHub Analytics webhook. There's also a corresponding K8s repository, so GitHub Analytics K8s and webhook K8s. There's Fortune Service, Greeting UI, the documentation of Spring Cloud Pipelines, trial of Pivotal Web Services, and PCF Dev. So the pictures were taken because I want to show you some other links as well. So read the docs, talk to us on Gitter. So for those who don't know, Gitter is a chat for GitHub projects. I try not to sleep and answer all of the questions, so try it. And that's it. So if you have any questions, it's time to ask them now. Questions? Who thinks that those pipelines make sense? Yay! Okay. Very good.
My question is,
very good question. The question was, like the project evolves, how can you, let's say, customize in such a way that you don't have merge conflicts with the origin? Very good question. So I'm not going to touch this laptop. You know, that's going to be better. So there is a convention. So for example, I've shown you this build and upload SH file, right? When we run the pipelines, check if under the custom folder in the same location, you have a, like in the same location, you have a file called custom slash, like, you know, folder custom slash build and upload SH. So what you can do is install all the hooks, like extension points, in your custom scripts, and always pull changes from us. You won't have merge conflicts for sure. Maybe we'll break something, right? Because these are milestones, right? But I try to make really good release notes saying this breaks, use this, right? So maybe you will have to, you know, follow some manual work, but you will be able to merge without any problems, hopefully.
And you can check, once you upgrade, you can check the BATS tests against your customizations as well.
Oh yeah, those bash tests, that's true, that's true. Or you can write your own BATS tests, whatever. Very good.
You mentioned that you manually create services in production. Why not have them automated as well?
That's a very good question as well. So we could automate this, but I would be a little bit scared that for some reason, for example, you have a, you know, database in production, and somebody messed something up, and this database gets deleted and recreated upon every service deployment. That's the only reason, because of course it would make sense. Even for stage, we had this discussion, and for stage, I would assume that most likely you're going to do it still manually. So for like only for security reasons. But if you're so secure, like so sure that things will work fine, you can customize the current way and deploy also to production from, let's say you set up services on production too.
Okay, and I would also add that currently the pipelines don't do a CF update service or update cups. So until they do that, you might not want to, if you're changing something, it won't understand. It'll think it's already there and won't issue it.
There was a question, yeah, back there.
Yeah, so would you generally have a copy of the pipeline repo for each service you're deploying? Would you have like one for your report?
Very good question. So the question was, would I have a copy of the pipeline for every service or not? So essentially, in one of my previous jobs, there was the situation that every team had their own pipeline, their own way of doing things, their own scripts, their own health check endpoints, everything of their own. So whenever you changed projects, you had to learn everything from scratch, like the stupid things. So I more believe in such a way that you have this centralized, and for example, go to GitHub, stash, whatever you have, and scan all the projects, and for each and every one of them, generate the same pipeline. But, of course, you can, let's say, change it in such a way that, like, essentially what the pipeline does is it clones the code of the Sprinkle pipelines, right? And executes the scripts from the clone, right? So whatever pipeline you create, well, like with Concourse, you can put it still with the apps. It's not a problem. They can reuse the scripts from Sprinkle pipelines. It would be a little bit more problematic with Jenkins because, for example, you would have this Jenkins DSL. There's a little bit of code there, right? But still you could do it. It's not a problem. So you can pick both options. I am more believing in the centralized way. There you go.
So we have a similar pipeline that we're building out.
Everybody has.
That does the database deployment using Flyway.
Yes.
And so we push the database, then we bring up a version of the application as it is currently the release version of the application, have that test, and then run the tests for that app against using that database. The problem is, which version of the application do we use, right? If you have multiple environments, so you have dev,
You have multiple.
test,
Yeah. Okay. Very, very good question. So, for example, you're using Git flow. You have different release branches. You got different releases, and which version to test against, right? Very good question. So, currently in Sprinkle pipelines, we believe in this simplified version of Git flow. So, you have master from which you release and a feature branch. That's it. So, to make it really, really simple. So, whenever you merge to master, you go to production. That's the idea. We don't yet support the Git flow approach. Let's say that you have different versions, or not even Git flow, but different release versions approach, that you have different release versions running there somewhere on production. We have an issue for that, so we will have an answer for you. Most likely you can do it let's say via some conversion of tagging, because we do it right now. So since we only release from master, we have only prod/version number tag. But maybe you would change this way, right? So you tag differently. Let's say prod/ maybe major. I'm just inventing it right now, like major, and let's say minor afterwards. So then, when you wanted to, if you want to do, let's say, rollback compatibility, so API compatibility or rollback tests, you would search for the latest tag in a different way, not prod/, but maybe prod major/, and then you would find the proper version. But we would have to sit down and analyze if that makes any sense. I guess it does, but maybe not. More questions? Do we have any time for questions? I guess so. Questions? Okay, if you're shy, so you can ask the questions like after this talk. And if that's it, so thank you very much. And sorry for the issues.